Let's take this problem 63 of your textbook. Uh, this says that small balls A and B, each of mass M, are joined rigidly to the ends of a light rod. Light rod means the rod is not a part of the system and of length L. So these are the small balls A and B. They are connected by a light rod of length capital L. The system translates on the frictionless, there is no frictionless horizontal surface with a velocity v naught in the direction perpendicular to the rod. That means this is a v naught, this is v naught, and the couple rather is the kind of a dumbbell. It is translating. Now, mind it, they have mentioned that both A and B are balls. That means they are translating with the balls rotating. No, they are not dragging on the tape. The two balls are rotating and they are translating. Now what happens? A particle P of mass M, once again, same mass M, kept at rest on the surface, sticks to the ball A as the ball collides with it. That means somewhere here there is a particle P, again of mass M. Now, when this couple or the dumbbell A and B comes at this position, A and B, the particle P sticks to B. That means this is now becomes a combination of B and P, and its mass becomes 2A. So question is, find the linear speed of the balls A and B after the collision. So the ball was first here, the body was first here, it has moved and come here. Say this was situation 1 and this is situation 2, when the particle P has stuck to the ball B. Now, we want to find out what is the velocity of A and B at this time. Let us say, after sticking, the velocity of A is VA, and this velocity, combined velocity, is V, B and P together. B and P together. Now, solving this will not be difficult at all. What is the initial momentum of the point B? We write it this way: initial of B. I think you understand the designations. Momentum is for P, I for initial, and this B for the B ball. Initial momentum of the ball B was its mass M and velocity V0. And final momentum of mass B also is its mass into, we have considered final velocity. That is, I have made a small mistake here. This one is designations. This one was B and this ball was A. Okay. Now, initial momentum of the ball B was V0 into m, and final momentum is m, mass m, and we have considered its velocity as b, vb. Similarly, with this correction, this becomes vb, and this is v a and p, v a and p, right? So these two momentums are same. Therefore, you can write so mvb is equal to mv naught. So velocity vb, that means velocity of the point v after collision, is equal to velocity of the point before collision. This is one thing, first thing. We do the same exercise for the point A. So initial momentum of A is mv naught, and final momentum of A and P together. Final momentum of A and P together. We have considered this velocity as VAP. VAP multiplied by its mass is now 2m. So, by conservation of momentum, V, A and P together multiplied by 2m will be equal to mv naught. From here we get the V, A and P together is equal to V naught by 2. So answer of the part A is done. That means what are the linear velocities of these two ends of this dumbbell? One end is B, another end is A and P together. What are their linear velocities after the collision? There was a second question. Second question was, question B was, the velocity of the center of mass of the system ABP. Velocity of the center of mass of the system. Now, momentum of B after collision, momentum of B, we go here, say, or B. Total momentum of the system, total momentum of the system after collision total momentum of the system after collision is the momentum of B after collision, which is mv0, and momentum of A plus P after collision equal to momentum of P after collision. I write this way. Momentum of B after collision plus momentum of A and P after collision. After collision. The momentum of B after collision is mv0 because B mass is m and after collision its velocity was v0. And momentum of A plus P after collision is 2m multiplied by, we have found the velocity of the two balls together is v0 by 2. Right? So here this 2 and 2 gets cancelled, so it becomes 2m v0. 2m v0. Now, total mass of the system after collision, total mass of the system after collision is equal to 3m. Say velocity of the center of mass, say velocity of the center of mass is equal to vcm. Then what is the momentum of the system? Then momentum of the system is equal to 3m multiplied by vcm. And we have already found the momentum of the system to be 2m v0. And on the other hand, we found it is equal to 3m vcm. So we can write, so 3m vcm is equal to 2m v0. This m gets cancelled. So velocity of the center of mass is equal to 2 by 3 v0. 2 by 3 v0. This is the velocity of the center of mass. The question had another point. Another part. This part is find the angular speed of the system about the center of mass after the collision. What will happen actually if you really see after collision, you can put it this way, after collision, what happens? The dumbbell has two masses here. And we have seen the velocity, linear velocity of V. Linear velocity of V is only V0, whereas linear velocity of A and P is V0 by 2. This is V0 by 2. This is V0. That means linear velocity of these two masses together is half. So obviously you can see that this dumbbell will have a rotating effect. This dumbbell will have a rotating effect in this direction. It will have a rotating effect in the clockwise direction. They want us to find out the angular speed of this rotating system. Now, this also will not be difficult. Part C, let us say this is part C. What is the angular momentum of B? Oh, by the way, where is the center of mass? Here it is M and here it is 2M. So obviously center of mass is here where this part is 2L by 3. You need not do calculations of the center of mass. It is very obvious from the diagram itself, right? So this is the center of mass. This is the center of mass. The angular momentum of B, angular momentum of B, that means this body is its momentum perpendicular to the axis of rotation multiplied by the distance from the axis of rotation. I write by the formula, its formula is equal to mvr. This is the formula. And this becomes mass of B is m, velocity of B is v0, and distance from the axis of rotation is 2L by 3. Right? So it is 2m v0 L by 3. 2m v0 L by 3. This is the angular velocity. This is the angular velocity. This is the angular momentum of the system. Angular momentum of B. Let us find out angular momentum of the combination A and P. Angular momentum of A and P together by using the same formula. Its mass is 2m. Velocity of A and P together is, we have found V0 by 2. V0 by 2 multiplied by its distance from the center of axis of rotation is L by 3. So this becomes mv0L. This becomes mv0L by, this becomes mv0 by L by 3. Now, one thing you have to understand here very clearly. Angular momentum of B is more than the angular momentum of A and P together. That is very obvious because A and P together is mass is down. So its net angular momentum will be the difference between the two, because this body will try to oppose the angular momentum of B. Shall I write it? I think if I write it, it will be better for you. Angular momentum of A and P will oppose the angular momentum of B. This you have to understand from the system. Angular momentum of the heavier body will oppose the angular momentum of the lighter body. I need a little bit more space here. So, the momentum of the lighter body. If that is so, therefore, so net angular momentum of the system is the difference of the two. That means 2 mvl by 3, 0, 2 mvl V0 L by 3 minus M V0 L by 3 minus M V0 L by 3. This is equal to, we are left with only M V0 L by 3. This is the angular momentum of the system. Now we use the relation angular momentum is equal to I omega. Then we shall immediately find out the value of omega, right? So we need to know the I of the system, moment of inertia of the system. Moment of inertia of the system. This is a very light rod. The rod is not a part of the system. So moment of inertia will be just mr square plus mr square. Mass of the B is only m, and its distance from the center of mass, that is center of rotation, is 2L by 3 whole square plus another mass is 2m and its distance is L by 3 whole square. L by 3 whole square. This makes it m 4 L square by 9 plus 2m L square by 9. This makes you 4 plus 2, 6 by 9 ml square, which is equal to 2 by 3 ml square. If we have understood that, then I omega is equal to the angular momentum. So I is 2 by 3 ml square, or we can, so I can write here omega equal to L by I. Now I is 2 by 3, L is given, L we have found, net angular momentum is mv0 L by 3. So this is mv0 L by 3 divided by this moment of inertia. So we have got 3 in the numerator and 2 ml square. 2 ml square. So out of this we have this 3 and 3 get cancelled. M and M gets cancelled. So we have V0 by 2L. So this is the angular velocity. And then in part C, this is a part C. In part B, we found out the velocity of the center of mass. And in part, this is part B. And in part A, we have found something else. Okay. So that's it. Then we go to the next problem.